Friends, welcome to the class. Today we will learn the most important concept in this chapter, lines and angles. That is the types of the angles which is made by the transversal. Okay, and depending on that we will try to get the or prove some of the theorems and two more problems. Okay, first of all we will recall the things, what is transversal, what the different types of angles depending on the transversal. Okay, transversal is a line which passes through more than two lines at a time and at distinct point. Okay, transversal is a line which passes through more than two lines in a distinct point. So imagine these two are this is, I am writing line M and N, and transversal L which passes through these lines at O and P, at point O and P. Now you can see it will create 8 angles if this transversal passes through two lines. I have named angles as 1, 2, 3, 4, 5, 6, 7, 8. Just naming the angles. And we will just go through the types of angles here. One is exterior angles. Exterior angles means if two lines are there and one transversal passes through the two lines, then the exterior angle are those angles which are outside the these lines. That is 1, 2, 7, 8, which are exterior outside the lines. So these 4 are exterior angles. I can tell with this example from the figure, the exterior angles are 1, 2, 7, 8. 1, 2, 7, 8. So the inside we are considering between the lines, those angles are interior angles. So that here the interior angles are 3, 4, 5, 6. In this figure, exterior angles are 1, 2, 7, 8 and interior angles are 3, 4, 5, 6. Please note down. Okay. Next, come to the corresponding angle. Corresponding angle are those pair of angle. Here, one exterior angle with corresponding with the interior angle, and it should be on the same side of the transversal. Let me take for the angle 1 in this diagram. The corresponding angle is 5. See, this is exterior angle, this is interior angle, which is on the same side. This exterior angle depending on the first line, this interior angle depending on the second line. So these two are the corresponding angle. Similarly, for 2, the corresponding angle is 6. For 4, the corresponding angle is 8. You can observe this is the interior angle and 8 is the exterior angle. The corresponding angle for 3, which is equal to 7, that already I have written. The corresponding angles for 1 it is equal to 5, for 2 it is equal to 6, for 4 it is equal to 8, for 3 it is equal to 7. Therefore, 1 and 5 are corresponding angle, 2 and 6 are corresponding angle, 4 and 8 are corresponding angle, 3 and 7 are corresponding angle. Next, come to the alternative interior angle and alternative exterior angle. We know interior angle, those angles which in between these two lines. So alternative interior angle means if you are considering one interior angle and it is connected, or it is the alternative interior angle for this angle is the angle in the next line which is also in the interior but the other side of the transversal. See, these 4, it is an interior angle. For this interior angle, alternative interior angle is 6, because these two are interior angle on different lines and on both sides, other side of the transversal of 4, right? For 4, 6 is the interior angle. For 3, 5 is the interior angle. Only 2 pairs of alternative interior angle we are getting if two lines and one transversal. So alternative interior angles are 4 and 6, 3 and 5. Similarly, alternative exterior angle are 1 and 7 and 2 and 8. You can observe it is alternative exterior angles. Okay. Next, come to this interior angle on the same side of the transversal. Here we have to consider the interior angle, and the angle should be on the same side of the transversal. If it is different side, then it is a exterior alternative interior angle. If it is same side, it is an interior angle on the same side of the transversal. Let me take for 4, the interior angle on the same side is 5. For 3, the interior angle on the same side is 6. You can observe for 4 it is 5, for 3 it is 6. Therefore, interior angle on the same side of a transversal is 4 and 6. Second pair is 3 and 6. Or sorry, 4 and 5. Second pair is 3 and 6. We are also naming this interior angle on the same side as consecutive interior angle, or co-interior angle, or allied interior angle. We can name interior angle on same side as consecutive interior angle, or co-interior angle, or allied interior angles. In the next topic, we will see two axioms which are related to two parallel lines and one transversal. We know transversal which passes through two lines in distinct cases. Consider these two are parallel lines. Okay, taking two parallel lines and one transversal passes through these two lines at point B and C. Now look at here, the corresponding angles are same. 80 which is equal to 80, 100 which is equal to 100, 100 and 80. So in the case of this, the corresponding angles of this figure are same. That is nothing but the axiom 3 and 4, the corresponding angle axiom. If a transversal intersected two parallel lines, then each corresponding angles are equal. Why it is so? Let me take one line and take one angle which angle is 60 degree. Okay, take another ray at another point on the line which is also making 60 degree. Okay, it's also making 60 degree. Now you can see these are two angles at different point and different ray OA and O dash, A dash, and the line RQ. Okay, if we extend this line OA to till B and O dash A dash till O dash B dash, and if we rotate this, you can see these two are parallel lines and one transversal passes through this, so that you can observe these corresponding angles in the parallel lines are same. Therefore, we are getting the corresponding angles of two parallel lines and one transversal which is same. In the converse of the axiom 3.4, if a transversal intersected two lines, and the corresponding such that a pair of corresponding angles are equal, then the two lines are parallel to each other. You can observe if a transversal passes through the two lines, then each pair of its corresponding angles are equal, then we can directly test that these two lines are parallel. Clear? Parallel ಆಗಿದ್ರೆ transversal pass ಆದರೆ corresponding angles same ಆಗಿರ್ತದೆ, or transversal ಎರಡು ಲೈನ್ ಅಲ್ಲಿ ಪಾಸ್ ಆದ್ರೆ corresponding angles same ಆಗಿದ್ರೆ ಈ ಎರಡು ಲೈನ್ parallel ಅಂತ ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ಬೋದು using corresponding angle axioms, axiom number 3.4 and 3.3 in your textbook. Next, we will see using this axiom, we will try to prove some of the theorem. Like here, you can observe PBC is 100 and BCS is also equal to 100. QBC is equal to 80. BCR is equal to 80. Now you can observe interior alternative interior angles are same here when two parallel lines and a transversal passes through these two parallel lines. And you can observe the alternative exterior angles are also equal, and some of the allied angles is 180 degree. Some of these two, angle B and C, which is equal to angle B plus angle C is equal to 180. You can observe in this case also the interior angles on the same side, their sum is 180 degree. All these things we have in the next theorems. We can use axiom 3.3 and 3.4 to prove all this concept. Okay. The first theorem based on the two parallel lines and transversal is, if a transversal intersect two parallel lines, then each pair of alternative angles is equal. As you saw in the previous figure, the alternative angles are equal if two parallel lines are there and one transversal passes through it. We will prove it theoretically. And what are they given? How to prove? The proof of this theorem is like this. Given AB and CD are parallel lines, or you can write AB is parallel with CD. Okay, these are given. What we have to prove? To prove angle, let me take this as Q. Yes. We have to prove angle AQR, which is equal to angle QRD, and angle BQR, which is equal to angle QRC. These two alternative interior angle are same, that we have to prove. Okay, and let me prove. First, we will take the angles PQA and QRC. We have angle PQA, which is equal to angle QRC. Look at here, this angle and this angle are same. Can you give the reason? It is nothing but the corresponding angle. Using corresponding angle axiom, we can tell angle PQA is equal to QRC. And look at these two angles, PQA and BQR. PQA which is equal to BQR. Look at this, PQA and BQR. These two angles, I am telling, those are same. It is vertically opposite angles, isn't it? It is vertically opposite angle. We know if two lines are intersecting, then the vertically opposite angles are same. So now you can observe PQA is equal to QRC and PQA which is also equal to BQR. Take this as equation number 1, this as equation number 2. Now from 1 and 2, the left hand side are same, PQA and PQA. If these PQA which is equal to QRC as well as BQR, then QRC is equal to BQR. QRC is equal to BQR. ನೋಡಿ, ಇದು ಆಂಗಲ್ ಇದಕ್ಕೆ ಈಕ್ವಲ್, ಸೇಮ್ ವೇ ಇದು ಆಂಗಲ್ ಇದಕ್ಕೆ ಈಕ್ವಲ್ ಆದರೆ these two angles should be same. Similarly, I can prove AQR which is equal to QRD. ಹೀಗೇನೆ ಈ angle ನ help ಇಂದ I can prove these two angles are also same. Hence the proof. Therefore, we can tell if two lines are parallel, alternative interior angles are same. The converse part of this theorem is nothing but the theorem number 3.3 that tells us if alternative interior angles same, which is created by the transversal, then the two given lines should be parallel. That we will prove in the theorem number 3.3. Okay, this is the converse theorem of theorem number 3.2, the theorem number 3.3. It tells us if a transversal intersecting two lines such that alternative interior angles are same, then these two lines are parallel. Please look at this statement. Whether it is a theorem number 3.3 or 3.4, you should understand. In a transversal, two lines are it passes through two lines such that the pairs of interior angles are equal, then those two lines are parallel. Here they are given the transversal PQ passes through two lines AB and CD such that angle AQR is equal to angle QRD and angle BQR is equal to angle QRC. These are given. The alternative interior angle are same. That is the given thing. What we have to prove? We have to prove AB is parallel to CD. In the earlier theorem, it is AB and parallel with CD is given. We have to prove this. Alternative interior angles are same. That we already did in the theorem number 3.2. In this theorem, which is given that the alternative interior angles are same, then we have to prove AB is parallel to CD. Okay, we will prove it. And here angle BQR is equal to angle QRC. BQR is equal to QRC, which is given thing, right? Alternative interior angles are same. And we know angle BQR which is equal to angle PQA. Angle BQR which is equal to angle PQA. Why this is so? Because it is vertically opposite angles. Vertically opposite angles are always same if two lines are intersecting each other. Then you can say that angle PQA is equal to angle, therefore angle PQA is equal to angle QRC. From these two, BQR is equal to QRC, BQR is also equal to PQA. So angle QRC is equal to angle PQA. Now just observe this thing. These two are the corresponding angles for two lines and this transversal. And therefore AB, which is parallel to CD, because the corresponding angle PQA is equal to QRC. Since the corresponding angles are same, these two lines are parallel. The reason is corresponding angle axiom. From the corresponding angle axiom, we can tell two corresponding angles are same, then these two lines are parallel. That we have to prove in this theorem 3.3. Just go through this proof and don't confuse the theorem number 3.3 and theorem number 3.2. Okay, the proof of the 3.3 and 3.2, which is very simple, isn't it? Similarly, try to prove 3.4 as well as 3.5. 3.4 states that if a transversal intersected two parallel lines, then each pair of alternative interior on the same side is of the transversal is supplementary. Supplementary means the two angles sum is equal to 180. ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ alternative interior angles or allied interior angles on the same side of the transversal, their sum is equal to 180, or those two angles are supplementary. ಈ ಎರಡು ಆಂಗಲ್ ಅದು ಸಮ್ 180 ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಈ ಲೈನ್ಸ್ ಆರ್ ಪ್ಯಾರಲಲ್ ಆಗಿ ಒಂದು ಟ್ರಾನ್ಸ್ಫರ್ ಪಾಸ್ ಆದ್ರೆ ಇದೆರಡರ ಸಮ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 180 ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಆರ್ ದ ಸಮ್ ಆಫ್ BQR and QRD should be equal to 180. That is the theorem number 3.4. In the theorem number 3.5, if a transversal of two lines such that two pairs of interior angle on the same side of a transversal is supplementary, then the two lines are parallel. This is the converse of the statement of theorem number 3.4. ಇದರಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ, if two lines are there, one transversal which passes through two lines, then the corresponding interior angles on the same side of the transversal which is supplementary. ಇದೆರಡು angle sum, interior angle on the same side do sum 180 degree ಆದರೆ ಎರಡು ಪೇರ್ ಅದು, then these two lines are parallel. ಇದು theorem number 3.5. Okay, try to prove these two theorems. I will briefly explain this. We know if two lines are parallel, to prove 3.4, two lines are parallel, then the alternative interior angles are same, right? The sum of this is 180 degree, right? If it is x, this is 180 minus x. I will try it briefly. If it is x, this is 180 minus x. This is equal to this angle BQR, which is equal to QRC, because this is alternative interior angle. Now take the sum of these two, 180 minus x plus x. X is so that angle BAQR and QRC sum is equal to 180 degree. Therefore, these two angles are supplementary. Similarly, BQR and QRD are supplementary. We can easily prove. Okay. For this theorem, you should take two lines and think if these are the supplementary angles. Okay, that means the sum of these two is equal to 180. Right? If it is x, then it is 180 minus x. If it is 180 minus x, then it is x. Then think of this. If this is 180 minus x, then this angle is, total angle is 180. In that, if you delete 180 minus x, then the remaining angle is this, right? If you delete 180 means 180 minus 180 plus x, so this becomes the x. If this is x and this is also x, that means the corresponding angles for these two lines are same and for this transversal. If the corresponding angles are same, then we can easily tell that these two lines are parallel using corresponding angles axiom. So it is easy to prove these two theorems. Try to prove these two theorems. In the next video, we will see some of the examples and some more the two theorem which is very important. Okay, it's enough today. Thank you.